Today we're going to take a look at an alternate approach to graphing quadratics, something that works all the time so you don't have to memorize standard form, vertex form, and intercept form. And we're going to start with a simple linear equation just to get our foundation and so we understand what we're doing when we move on to quadratics. So if I was to graph this, y equals x plus 2, my y-intercept is 2, and my slope is 1, go up 1, down 1, and your graph would look something like this. Alright, suppose we rewrote this. Y equals x plus 2. Suppose we rewrote it as y is equal to x plus 1 plus 1, which these are the same exact thing. If you take this x plus 1 and set it equal to 0 and solve it, you'd subtract 1 from both sides and you get x is equal to negative 1. Now if you were to make a table and plug in negative 1, plug negative 1 into here and you get 0, and you get 1 as an output. So notice that this 1 syncs up with this 1. So I know that negative 1, 1 is a point on my graph, which it is right there. Now we can do the same thing. Let's write this as y is equal to x plus 3 minus 1. So 3 minus 1 just gets you back to your 2, and we take x plus 3, set it equal to 0 and solve that. We get x is equal to negative 3. If I made another table, plug in negative 3, you'll see that you get negative 1 as your output. So negative 3, negative 1 is also a point on your graph. And we could do this all day. Y is equal to x minus 4. If I have a minus 4, I have to do plus 6. 4, 6 is going to be a point on your graph. So over 4, up 6, right there. Keep this in mind as we work through the quadratics, because it's kind of the same principle. In order to work through these problems, we need to know a couple things. First, you need to know that the axis of symmetry is halfway between any points with the same y values. So it's between a 1 and a 3. The y values are the same, they're 2's. Here the y values are both 5's, and your axis of symmetry is between these 2 points. Also, you need to know that if you plug your axis of symmetry into the function, you will find the min or the max of the parabola. The min or the max is the height, it's the y value of the vertex, and you also need to know that the vertex is the point where the axis of symmetry and the y value are. Your max or your min. So it's where your graph either begins to open up or it opens down. It's that point. So if we were to graph this first function here, this is written in standard form. Typically you'd have to find negative b over 2a to find the axis of symmetry and plug that value in. But what I'm going to show you guys is a method that works all the time. What we're going to do is group these first two terms together. And we're going to factor out whatever's common in both of those. I'm going to factor out a negative 3x, and I'm left with x minus 2. And then I have a plus 4 on the end. And if you're not sure, negative 3x times x gives me negative 3x squared, and a negative 3x times negative 2 gives me a positive 6x. Now, just like before with the linear equation, we're going to take negative 3x and set it equal to 0 and solve this. You get x is equal to 0. Take this and plug it into this function or this function, and you'll know that when you plug it in, you'll get a 4. So if you made a table, you'd get a 4. So we know that 0, 4 is a point on our graph. Now we're going to take x minus 2, set it equal to 0, you get x equal to 2, and we're going to do the same thing. If you plug 2 into either of these, you're going to get a 4 out, so we know that 2, 4 is a point on our graph. Plot these, alright, and we know the axis of symmetry is directly in between these, so I know my axis of symmetry is 1. What we're going to do is take 1 and plug it into our function to tell me the height, or the min or the max. Oops. Alright, and we'll get a negative 3 plus 6, which is 3, plus 4, which is 7. So now I know at over 1 up 7, that is my vertex, and this is going to open down. We know because it's negative. Alright, my graph will look something like that. Alright, in this second graph here, I can group this. It really doesn't do much because I don't have a b term. What I could do is rewrite this as x times x plus 2. So it looks something similar to this over here. We'll take x, set it equal to 0, and you get x is equal to 0, and it'll happen for both of these. So I know that 0, 2 is a point on my graph, and it works for both of these x values. So if 0, 2 works for both of them, that means that that point is your vertex. All right. From here, your best bet is just to make a table, plug in like a 1 and a 2, reflect them over your axis of symmetry, and you'll have the shape of your parabola. Alright, so if I plugged in a 1, I got a 3 out. If I plugged in a 2, I got a 6 out. So over 1 up 3, over 2 up 6. I reflected these over this axis of symmetry here at 0, and there's the shape of your parabola. On this last graph, we have x plus 1 squared. That's x plus 1 times x plus 1, and then we have a minus 3. We're going to take x plus 1, set equal to 0, and solve it. You get x is equal to negative 1. So negative 1, and whatever hangs on the end, negative 3 is a point on the graph. The same thing would happen over here. So this is very similar to the last problem where negative 1, negative 3, that's also my vertex because both points are the same point. All right, my axis of symmetry is right here. All right, and all we're going to do from here is make another table like we did before. Pick some x values, let's pick 0 and 1, and plug them in and plot the points, reflect them over the axis of symmetry. Alright, so if I plugged in 0, I got negative 2. If I plugged in 1, I got 1. So 0, negative 2 is here. I reflect this over, I get another point, and 1, 1 is right here. And if I'm 2 away from the axis of symmetry, just go 2 away over here, and our quadratic will look something like this. Alright, we'll take a look at 3 more examples, and we'll be done. Alright, in this example, we actually don't have a plus anything, so we're going to write a plus 0 in here. And just like before, I'm going to group these first 2 terms together and factor out anything common in both of them. Since we're dealing with a fraction, all I'm going to really take out is the x, and I'm going to rewrite this as 1/2 x plus 3 plus 0. Alright, if we take this, set it equal to 0, I get 0. And I know that 0, 0 is a point on my graph, because 0 is on the end here. We have to take what's in parentheses here and set it equal to 0, and then solve this. We'll get 1/2 x is equal to negative 3, so x is equal to negative 6. And now I know that negative 6, 0 is also a point on my graph. Right? If negative 6 and 0 are my x-intercepts, I know that my axis of symmetry is at x equals negative 3. What we're going to do is take negative 3 and plug it into our function and evaluate it, and that'll give me the height of our vertex. Right? When we plug this in, we get negative 4.5. So I know that negative 3, negative 4.5 is my vertex. All right, and we can see what our parabola is going to look like. Now keep in mind, this 1/2 tells us that it's going to open up, and because it's a fraction less than 1, the absolute value of it, it's going to be a little bit wider than our traditional parent function y equals x, or f of x equals x squared. In this next example, let's write this as negative 1/3 times x plus 3. If I take, we're going to take this and set it equal to 0, and we'll get x is equal to 0. The same thing will happen here. So I know that 0, 3 and 0, 3 are both points on my graph. They happen to be the vertex because they're the same. Right? And from here, just like in the problems on the previous slide, we'll just make a table and plot some additional points. And then we'll just draw a parabola. Alright, so when I started making this table, when I plugged in 1, I got 2 and 2/3. When I plugged in 2, I got 1 and 2/3, which are difficult numbers to graph. So I continued my table. I plugged in 3, and when I got a 0 out. So that's a nice number, nice and easy to graph. 3, 0. I know that negative 3, 0 is also a point on my graph. Right? And our parabola looks something like that. Right? Our last graph here, remember this is a plus 0 on the end. I'm going to rewrite this as 2 times x minus 4 times x minus 4 plus 0. And now I know that 4, 0 and 4, 0 are both points on my graph. Alright, so I also know that's my vertex. And just like the problem before this, once we know the vertex, all we're going to do is make a table and plot some additional points. So let's pick 5 and 6. Plug these into our function, plot them, reflect them over the axis of symmetry, and you're done. Alright, when I plugged in 5, I got 2. When I plugged in 6, I got 8. We're going to reflect these over the axis of symmetry. Alright. And our parabola will be fairly narrow because this is a 2, and it'll open it up because it's positive.